R4, factoring polynomials. As a continuum of our refresher and review of previous material that we've done in other classes, we're going to work on factoring polynomials. Now, remember that factoring is the process of finding polynomials whose product equals the given polynomial. And optimally, when you are factoring, you want to go down to the smallest factors you can. When dealing with polynomials, those are called prime polynomials. Prime polynomials are polynomials that cannot be factored further into other polynomials, be it a monomial, binomial, or whatever the case may be. So that's what we're looking at this point, is we want to be able to break down factors. It's kind of like, if you remember prime factorization, when you have a number and you break it down into the smallest numbers you can, or factors, the prime numbers. Such as, if you have the number 24, with prime factorization, you start pulling out prime numbers. Pull out a 2, 2 times what gives you 24? 12. Pull out a 2, 2 times what gives you 12? 6. Pull out a 2, 2 times what gives you 6? 3. So you have 2 cubed times 3, right? Prime factorization. You're trying to get down to the smallest numbers that multiplied together will give you the result. Same thing with factoring. We're trying to break it down into the smallest polynomials that, when multiplied together, will give the result you're looking for. So the first part of that is, or the first step you always do when you're factoring, is look for the greatest common factor. That is the first thing you always do when you're looking at factoring polynomials. Always pull out the greatest common factor first. So I'm going to put a couple up here so that we can look at them. So let's say we have 6a squared minus 18a to the fourth. And I'm going to put another one here, and I'm going to go 14x cubed y squared minus 28x squared y cubed plus 21x squared y squared, just to give us some examples to play with. So the first thing we always look for is the greatest common factor. So I see 6a squared minus 18a to the fourth. I look at the coefficients and I see 6 and 18 are both divisible by 6. So I'm going to pull out that 6. And I see a squared and a to the fourth both divisible by a squared. So 6a squared. 6a squared divided by 6a squared gives you 1. Negative 18a to the fourth divided by 6a squared. Negative 18 divided by 6 gives you negative 3. A to the fourth divided by a squared gives you a squared. And we just pulled out the greatest common factor. So let's look at another one. 14x cubed y squared minus 28x squared y cubed plus 21x squared y squared. So I see 14, 28, and 21. I see those are all divisible by 7. So I'm going to pull that out. I see x cubed, x squared, so I can pull out x squared. I see y squared, y cubed, y squared. I can pull out y squared. And why do I say I can pull it out? Because this has at least x squared in it, right? X cubed, x squared, x squared. I look for the lowest degree of each of those, and that's what I'm going to be able to pull out. So I pull those out, leaving me with 2x minus 4y plus 3. And this is really just going back to dividing by a monomial. Remember, I said you can divide by a monomial by dividing it into each of the terms. We just have to determine what the largest monomial is that we can pull out of here. So that's dealing with the greatest common factor. That works great when you have a monomial factor. largest thing we can pull out of it. But other times we have to do things a little bit more advanced, because maybe we have something that is not factorable by pulling out a greatest common factor, or the greatest common factor of all the terms is 1. So an example of that, 6x squared plus 9x, sorry, wrote that wrong, 6x cubed plus 9x squared plus 10x plus 15. Now, if I look at this, I have 6, 9, 10, and 15. Well, that's divisible by 2, 3, or 6. That's divisible by 3. So 2 and 6 are no good. That's divisible by 2 and 5. That's divisible by 3 and 5. Unfortunately, there is no common factor for the constant parts, the coefficients. And we got x cubed, x squared, x, and x to the 0. I can't even pull out an x. So we may look at this and go, well, we're done. We can't factor anything. But what we're going to work on now is not greatest common factor, but factoring by grouping. What I mean by factor by grouping is, maybe I can take part of the terms, or some of the terms, and find a common factor, and then take other terms and find a common factor. So what I'm going to do is, I have 4 terms here, so I'm going to split them in half and say, well, what if I look at the first 2 terms by themselves, and then the last 2 terms by themselves? If I do that, I see 6x cubed plus 9x squared. 6 and 9 are both divisible by 3. X cubed, x squared, both divisible by x squared, leaving me with 2x plus 3. Now if I look at 10x and 15, I see 10 and 15 are both divisible by 5, so plus 5. 10x divided by 5 is 2x. 15 divided by 5 is 3. And so I've got 3x squared times 2x plus 3, plus 5 times 2x plus 3. Well, wait a second. 2x plus 3, 2x plus 3. 2x plus 3 is now a common factor in these 2 parts. So I can factor that out. 2x plus 3, leaving me with 3x squared plus 5. I pulled them out, that's what was left over, 3x squared plus 5. So now I was able to factor this 4-term polynomial by looking at the first 2 terms and the last 2 terms separately, and then factoring. Now, why would we do that, or what are the chances that this is going to work out this way? Well, for demonstration purposes, we can set up something like this and you factor. Many times when you have a 4-term polynomial, you're not going to be able to just pull out common factors and have it work out this way. But where this comes in handy is when you have a trinomial and you're trying to factor that trinomial. Because we can use factoring by grouping to turn a trinomial into a 4-term polynomial that will then factor. So let's take a look at a couple examples so you can see what I'm talking about. Okay, so I'm going to flip over my paper here. Okay, let's look at 5x squared plus 4x minus 12. So 5x squared plus 4x minus 12. Now I look at this and I go, first thing I should do is greatest common factor. 5, 4, 12, nope, nothing that divides nicely into all 3 of those. X squared, x, no. So here's the process to use factoring by grouping to factor this. What we're going to do is we can think of this as being in the form ax squared plus bx plus c. If I think of it in that form. And what we're going to do is we're going to take a times c and find out what that is. And then we're going to take not put it that way. We're going to take a times c and find out what that is. So we're going to find two numbers, so we're going to get that. And then we're going to take b and get that. And we're going to say, give me two numbers that when I multiply them together, give me a times c. And when I add them, give me b. So let's say, just to keep off of that, let's go for d times e. D plus e. So I'm looking to multiply my two outer terms, the coefficients of my two outer terms, and I want to find two numbers that multiply to that value and that add up to this center one. Now, it may seem a little confusing as we put it off to the side, but watch what happens when we start to deal with this here. 5 times negative 12 is negative 60. So I'm looking for two numbers that will multiply to negative 60 and that will add to 4, to that center value. Two numbers that multiply to negative 60 and add to 4. Well, one thing we know is that the values are going to have opposite signs, right? If two numbers are going to multiply to negative 60, then they must have opposite signs. If they're both positive, you're going to get a positive result when you multiply. If they're both negative, you're going to get a negative result. So we know they have to have opposite signs, and they're going to add to a positive 4. So this tells me opposite signs, and this tells me that the larger number is positive. Okay? So let's look at factors of negative 60. So it could be negative, and I know the larger number is going to be positive, so I can just start with the smaller side being negative. Negative 1, positive 60. Negative 2, positive 30. Negative 3, positive 20. Negative 4, positive 15. Negative 5, positive 12. Negative 6, positive 10. All right, and that's as far as we get until we get negative 10, positive 6. But we know that the larger number has to be positive. Okay, and because of that, we say, well, wait a second. If I add those up, I get 59. If I add these up, 28, 17, 11, 7, 4. So we've got negative 6 and positive 10. Those are numbers that multiply to negative 60 and that add to positive 4. Now that I've done that, I'm going to use this to split up this 4x. So I'm going to stick with 5x squared, but now I'm going to say minus 6x plus 10x minus 12. Notice that negative 6x plus 10x adds up to positive 4x. So I haven't changed my trinomial. All I have done is split one of the terms up into two terms. Now I've got 4 terms I can factor by grouping. I've got 5x squared minus 6x. I can factor out an x, leaving me with 5x minus 6. I have 10x minus 12. I can factor out a 2 plus 2, giving me 5x minus 6. And look, there's my common factor again. So 5x minus 6 times x plus 2. And I have factored by grouping. I know I went through a lot of things. Let's try another one, because doing more examples is usually better in these cases, so we can better see what's happening. Key thing is, you're going to multiply the two outside coefficients to come up with a product, and then you're looking for two numbers that multiply to that value and add to the middle value. So let me grab another one here. (12b squared minus 5b minus 3). Remember, variables don't have to always be x and y, right? They can be other things. So I've got b squared, b. So the goal is multiply these two together. So 12 times negative 3 gives me negative 36. So I'm looking for two numbers that multiply to negative 36. And then they add to whatever this middle one is, negative 5. Answer is negative, so they're going to be opposite signs. The center term is negative, so you're going to have a larger negative value. Okay? So now I look at it, and you may be able to look immediately and see what will work for this, or maybe not. If you can see it immediately, great, go with it. If not, then do it by the side. I see this and I go, oh, wait a second, negative 36, negative 9 and 4 multiply to negative 36 and add to negative 5. But if you don't see that, then just come over and go, okay, we know the negative number's got to be larger, so the positive one's going to be smaller, so 1 and negative 36, 2 and negative 18, 3 and negative 12, 4 and negative 9, 6 and negative 6. I don't have to go any further because I know that my negative number has to be larger for it to add to a negative value. So that's very important that we notice that. So now I say, okay, well, which ones of these add up to negative 5? Nope, 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 yep, nope. So it's 4 and negative 9. So if you recognize it immediately, great. If you don't, just start factoring this value and see which ones actually add up to it. Now there is a much longer method for doing this that you really don't want to deal with, so I'm not going to teach it to you. Because personally I think it's a waste of time. But factoring by grouping, well, it works great. So now what we're doing is we take these values that we just found and use it to split this up into two pieces. So I've got 12b squared minus 9b plus 4b minus 3. All I'm doing is those two terms right there are that. Minus 9b plus 4b gives me negative 5b. Now that I have that, 12b squared minus 9b, I can pull out 3b, leaving me with 4b minus 3. And 4b minus 3, greatest common factor is 1. Now, this is where you have to be careful. People make mistakes at this point. You always have to factor something out of this. The greatest common factor is 1, so plus 1 times 4b minus 3. 4b minus 3, 4b minus 3, you can factor that out. 4b minus 3 times 3b plus 1. So there we go. Now you may ask the question, but what if I don't put these in the same order as you did? How did I know to put negative 9b first and 4b and plus 4b second so that it could factor out? Well, let me move my factors up here 4b minus 3 times 3b plus 1. And I'm going to get this stuff out of the way and reverse it. So let's use the 4b first. 12b squared plus 4b minus 9b minus 3. Okay, now let's see what happens. 12b squared plus 4b, I can factor out 4b, giving me 3b plus 1, minus 9b minus 3. I will point out to you that if you have a minus over here, always factor out that negative, that as a negative. So if you minus something, always factor out the negative. Even if this one is not negative, always factor out the negative if this first term of your second set is negative. So minus 3 giving me 3b plus 1. Oh look, I have a common term, a common factor, 3b plus 1. 3b plus 1 times 4b minus 3. And if you notice, 4b minus 3, 3b plus 1, it still came out with the same thing. So there is no wrong way to do it. If you reverse those two numbers, it's still going to come out with the same thing. It's not going to affect your result. It's going to affect the order of your result. But commutative property of multiplication says that doesn't matter. We can work with that. The key thing is making sure that the two numbers you choose add up to this product, multiply to that product, and add to that value in the middle. Multiply the outer terms, get that. You're looking for two numbers that multiply to that and add to the middle term. So that's factoring by grouping. And once you get used to it, it's actually a really easy method to use. Very consistent, as I said, much simpler and less time consuming than another method that does essentially the same thing, but basically would drive you nuts. So you don't want to deal with those other ones. Okay, well, let's look at factoring perfect square trinomials. So what if we have x squared plus 2xy plus y squared? Okay, if we are dealing with perfect square polynomials, meaning that the first term is a perfect square and the last term is a perfect square, chances are it's going to be one of a number of special products. But the first thing we can do is we can treat this just like we would factoring by grouping. We can still say, well, that's a 1, that's a 1, right? So we're looking for two numbers that multiply to 1 and add to 2. Now that may take you a little time to think through that, but obviously that's 1 and 1. So factoring by grouping, we can make it x squared plus xy plus xy plus y squared. Pull out an x, x times x plus y. Pull out a y, y times x plus y. Common factor of x plus y times x plus y, which can be written as x plus y squared. Look at that. Okay, so x plus y times x plus y gives us x plus y squared. This is a special product. And I'm going to put that up here is equal to x plus y squared, or the square of a sum. X squared plus 2xy plus y squared is equal to x plus y squared. Another one that's related to that, and I'm not going to show the full process behind it, is x squared minus 2xy plus y squared is equal to x minus y squared, the square of the difference. Another one, x squared minus y squared is equal to x plus y times x minus y, the product of the sum and the difference. So why do we care about these? Well, these special products allow us to factor anything that's in this form. And you should, whenever you're factoring, of course, first of all, you pull out the greatest common factor. No matter what else is happening, pull out the greatest common factor. Then, if you see that the first term and the last term are perfect squares, you're probably looking at one of these three special products. If it's in the form perfect square plus 2 times the square root of each of those, plus a perfect square, then you've got the square of a sum. If it's a perfect square minus 2 times the square root of each of those, plus perfect square, then it's the square of a difference. And if you just have a perfect square minus a perfect square, it's the product of the sum and the difference. So let's take a look at some of these and see what we're talking about. But those are special products, so we may see things and go, oh, perfect square, that fits into one of these. Oops. Let's not make that 24. Let's make that 12. Okay? So 4x squared plus 12x plus 9. I look at this, and yes, I can work my way through this doing factoring by grouping, because I can go 4 times 9 is 36. Two numbers that multiply to 36 and add to 12, 6 and 6. And I can go through and do this. So if I do it that way, the old way, then we see that we have, well actually, let me do it this way and then I'll show the old way just to back it up. So I see perfect square, I see that this is a sum. So my thought is, I must be looking at 2x plus 3 squared. The square root of the first term, the square root of the second term, and if I take 2 times these two terms, 2 times 2x is 4x, times 3 is 12x. And I get my result. So I came up with it that way. If I'd done factoring by grouping, I would have said 4 times 9 is 36. So I'm looking for two numbers that multiply to 36 and that add to 12. That's 6 and 6. So I take 4x squared plus 6x plus 6x plus 9. Factor out 2x. 2x leaving me with 2x plus 3. I would factor out 3, leaving me with 2x plus 3, giving me 2x plus 3 times 2x plus 3, or 2x plus 3 squared. But you see how simple that can be. I saw a perfect square, and I said, I can use one of my special products. Let's do another one. So I've got 100x squared plus 160x plus 64. 100x squared, perfect square. 64, perfect square. But before we do that, remember, we always pull out the greatest common factor. And with 100, 160, and 64, the greatest common factor would be 4. So I have 4, and it leaves me with 25x squared plus 40x plus 16. Perfect square, perfect square. Don't forget this 4 on the outside here. So the square root of 25x squared is 5x. The square root of 16 is 4. Well, let's see how this works. 5x times 5x plus 4, should say, is 20x. Plus 20x is 40x. 5x times 5x is 25x squared. 4 times 4 is 16. Multiply that by 4 and you get 100x squared plus 160x plus 64. So recognizing those special products can save you a lot of time, especially when you have something like this. 36x squared minus 81y squared. Well, you may look at that and go, well, I know I can factor out a 3 out of these, so that might be a good idea. If I can factor out a 3. But I think better than that, I see 36x squared minus 81x squared. If I factor out a 3, that's going to put me at 27. If I factor a 3 out of there, it's going to give me 12. So I can factor more out of that, right? What can I factor out? I can factor out a 9. There we go. So 9 giving me 4x squared minus 9y squared. Okay? So I was able to factor that out, and now I've got a perfect square, a perfect square. So 9 times, well, that's 2x. Now, this is a perfect square minus a perfect square. There is no middle term, which means I'm in the product of a sum and a difference. So plus 3y times 2x minus 3y. So using special products. And to check this, we can multiply it out, and it will get us back to 36x squared minus 81y squared. So factoring by grouping, doing special products. Okay, and that really covers what we need to know about factoring. So remember, greatest common factor, always pull out the greatest common factor. Once you've done that, look for perfect squares. If you got perfect squares, chances are you can do this. If you don't have perfect squares, factoring by grouping. And let me actually throw one more in here, which we kind of skipped over, but you should know the method. It's kind of halfway between factoring by grouping and greatest common factor. What if I have a leading coefficient that is 1? So x squared plus 5x plus 6. So if I have something that, a trinomial, where the leading coefficient is 1, this is really, could be considered a really simplified form of greatest common factor. Not greatest common factor, sorry, factoring by grouping. But really, all we need is, remember, 6 times 1 is 6. So we're looking for a product, two numbers that multiply to 6 and add to 5. In this case, those numbers are 2 and 3. And we can actually just break this up quickly and say that's x minus 2, sorry, x plus 2, and x plus 3. X squared plus 3x plus 2x gives you 5x plus 6. Don't believe me? Let's factor by grouping. Well, we come out with 2 and 3, so we have x squared plus 2x plus 3x plus 6. Pull out the x. Leaves us with x plus 2. Pull out the 3. Leaves us with x plus 2. Factor out the x plus 2. And we're left with x plus 3. So if your leading coefficient is 1 and you're factoring a trinomial, first thing you should do is see, can I find two numbers that multiply to the constant term and add to the middle term? If I can just build it immediately, x plus 2, x plus 3, instead of going all the way through factoring by grouping. Okay, so enjoy factoring.